Graphical interpretation. So what are graphical interpretation questions? In this type of questions, as the name suggests, we will come across different types of graph or visual data. The visual data might be pie chart, scatter plot, histogram, bar graph, line graph, organizational chart, bubble graph, and so on. One important aspect of graphical interpretation question is some graphical interpretation questions may have an accompanying text or paragraph. That accompanying text or paragraph is very important because sometimes some information which are not present in the graph are usually present in the paragraph. So we need to read and understand the paragraph properly. In this type of questions, generally 2 to 3 sub questions follow, where the options can be accessed from the drop-down menu. The format of the questions of graphical interpretation are in the fill in the blanks or complete the sentence format. And for this reason, in order to complete the sentence, we are given the drop-down menu. When we click on the drop-down menu, we will have access to the options. We need to select the correct option. And just like any question of data insights, here also, all the parts must be correct to claim credit for the question. Now, one concept that is sometimes tested in graphical interpretation questions is the concept of correlation. From the GMAT point of view, we are not required to deep dive into the concept of correlation. Rather, we are expected to relate it with the concept of slope of a straight line. And before working on the slope, we need to recap the basics of coordinate geometry. So let's get started with the basics of coordinate geometry. The two axes x and y divide the entire rectangular plane into 4 quadrants, which are numbered anti-clockwise. The axes are numbered according to the number line. The meeting point is taken as origin or 0, 0. The x-axis is numbered. On the right hand side is positive, like 1, 2, 3, 4, 5, and so on. On the left hand side it is numbered as negative, -1, -2, -3, and so on, just like in a number line. Similarly, the y-axis is numbered 1, 2, 3, and so on, and -1, -2, -3, and so on. In the first quadrant, both x and y are positive. In the second quadrant, x is negative and y is positive. In the third quadrant, both are negative, and in the fourth quadrant, x is positive and y is negative. So we can conclude that above the x-axis, y is always positive, and below the x-axis, y would be always negative. In the same track, we can say that on the right hand side of the y-axis, x is always positive, and on the left hand side of the y-axis, x would be always negative. Now suppose we are given a point 5, 3, and we are asked to plot it in the rectangular plane. In the standard Cartesian form, any point is represented in the form of x, y. So 5 will represent the x coordinate and 3 will represent the y coordinate. So x coordinate 5, the point should lie somewhere here. Y coordinate is 3, the point should lie somewhere here. So my point 5, 3 is this one. And this is how we plot point in the rectangular plane. Now let's move on to the concept of slope of a line. In the coordinate system, suppose we are given a line L and we are asked to find the slope of the line L. So what does the slope of a line signify? Slope of a line signifies the inclination of a line with the positive of the x-axis. Mathematically, it would be the ratio of change in the y coordinate over change in the y coordinate. This means to find the slope of a line, we need any 2 points on the line. Let us take any 2 points on the line, A and B. A and B are having the x coordinate as x1 and x2 respectively, and y coordinates as y1 and y2 respectively. Now, the change in the y coordinate would be y2 minus y1, and change in the x coordinate would be x2 minus x1, correct? Hence, the slope of the line is given by this ratio, which is y2 minus y1 over x2 minus x1. Now, the important aspect of slope that we need to relate with the concept of correlation is the concept of rising line and falling line. Let's work on this with the help of an example. On your screen, you can see two lines L1 and L2 accompanied by a question: which out of the two given lines, L1 and L2, will have a greater slope? Options are A, L1, B, L2, or C, cannot be determined. At times, we may feel that as no points are given on the lines, the relationship between the slopes cannot be determined. But that is not the case here, because from this point onwards, we also know that rising line or ascending line will always have a positive slope, and falling line or descending line will always have a negative slope. So how does one determine for sure which one is a rising line and which one is a falling line, right? Let's see. At first, rising or ascending line. Suppose we are given a line L1 in coordinate system. To determine whether it is a rising line, we will move from left to right. While moving from left to right, if the line rises, then it is a rising or ascending line. So the given line L1 is a rising line. Also, this one is a rising line, this one is a rising line, and this one is also a rising line, because in all these lines, whenever we move from left to right, each of this line rises. Another way to determine it is a rising line is by taking any 2 points anywhere on the line. Another way to determine it is a rising line is by taking any 2 points anywhere on the line and moving left to right. When I move from left to right, that is from A to B, my x coordinate would be increasing. When I'm moving from A to B, my y coordinate is also increasing in this case. So if there is an increase in the value of the y coordinate with an increase in the value of the x coordinate, my line is a rising or ascending line, and it will always have a positive slope. Now, falling or descending line. Similarly, we are given a line L2 in the coordinate system. To determine whether it's a falling line, here also we will move from left to right. While moving from left to right, if the line falls, then it is a falling or descending line. So this is a falling line, this is a falling line, this is a falling line, all these are falling line, because for all these lines, whenever I move from left to right, all these lines will fall, and any falling or descending line will have a negative slope. Another way to determine it is a falling line is by taking any 2 points on the line. Now when I move from left to right, that is from A to B, my x coordinate increases again, just like the previous example. But in this case, when I move from A to B, although my x coordinate increases, but my y coordinate decreases. Hence, if there is a decrease in the value of the y coordinate with an increase in the value of the x coordinate, my line is a falling or descending line, and it will always have a negative slope. Now as we go back to our initial question, we can see L1 is a rising line, so slope would be positive, and L2 is a falling line, so slope would be negative. Hence, the answer to the question is A. L1 will have a greater slope. Now we are ready to discuss correlation. There are 5 types of correlation: strongly positive correlation, no or negligible correlation, negative correlation, and strongly negative correlation. From GMAT point of view, we will relate correlation to the concept of slope of a straight line and nothing more than that. Let's see how. By that I mean, suppose I am dealing with this scatter plot and we are asked about the correlation between x and y. Now, to comment on correlation, we will not consider 2 points or 10 points, but rather we need to consider the entire sentiment or the trend of the graph. When we look into the scatter plot, can't we say that the overall sentiment of the graph is with an increase in x, the y tend to increase? Can't we say that? Yes, we can. So, had it been a straight line, it would have been a rising line having a positive slope, correct? Since the slope would have been positive, it is a strongly positive or positive correlation. Similarly, if the overall sentiment of the graph is with an increase in x, y tends to decrease, it would be a negative or strongly negative correlation. If there is no observable pattern, it would be no or negligible correlation. Now let's address the elephant in the room. How to differentiate between strongly positive and positive correlation and strongly negative and negative correlation. And more importantly, is this differentiation required? To answer to the question, we can differentiate between strongly positive and positive correlation and strongly negative and negative correlation with the help of another concept called correlation coefficient. But since this concept is not asked in GMAT, we can treat strongly positive and positive correlation as one and strongly negative and negative correlation as other. This is why treating correlation just like the concept of slope of a straight line is sufficient to answer any question in GMAT. Now let us try a graphical interpretation question based on correlation.